Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1, and today's chapter is gamma and beta function. In this chapter we have today's topic is beta function and its property, which is our second lecture of this chapter, which will be last. Now, first we will start with the definition of beta and then its property, and using that property we have some examples. Okay, so let's start with the definition. The beta function of m and n is denoted by beta mn, or we can say capital B of m comma n, and is defined by convergent improper integral integration 0 to 1 x raised to m minus 1 into 1 minus x whole raised to n minus 1 dx. Okay, this is a special kind of improper integral which depends on the parameter m and n. So as m and n change, this m and n change. Okay, so this integral depends on m and n. Thus, beta mn is given by this integration, this here. Okay, so this is the definition of beta function that you have to remember to prove the properties. So if I'm changing, if one example, like example is given 0 to 1 x raised to 3 and 1 minus x raised to 4. So what will be the answer? So beta mn. What will be the m and what will be the n? So you have to compare 3 with m minus 1. So m minus 1 is equal to 3. So m will be the 4, 3 plus 1. And similar way, n minus 1 is equal to this, n minus 1 is equal to this 4. So we have n is equal to 5. So we have 4 comma 5. Answer of this is beta 4 comma 5. How we can solve this beta 4 comma 5? For that we have to understand some properties. Okay, so let's start with the properties of beta function. Very first property, prove that beta mn is equal to beta nm. So as we have seen, beta 4 comma 5 which is equal to beta 5 comma 4, both are same. So now start to prove this property. Let's have a definition of beta function. This is the definition. Now we have to just change that beta mn to beta nm. So this will make n and this is m. For that we will suppose x is equal to 1 minus 5. So x is equal to 1 minus 5. So dx is equal to minus dy. So when x is equal to 0, if we put x is equal to 0, so y is equal to 1, and x is equal to 1 here, so y is equal to 0. Now put all this value in this definition. So we have 1 to 0, this 1 minus y because of x, and if we put here x 1 minus y, so 1 cancel, so we have y, and dx is minus dy, and you know that if we multiply minus with the integration, so this limit will be changed, so 0 to 1, and we have this. This is look like the definition. You can see this is the definition and this is our obtained integration. Both are same, but only variable is different. So x raised to m minus 1, so here m, and so here y raised to n minus 1, so first will be n. So we have beta n, and this is m minus 1, so m. So beta mn is equal to beta nm, commutative. Okay. Second property is beta mn is equal to 2 times integration 0 to pi by 2 sine 2m minus 1 theta into cos 2n cos raised to 2n minus 1 theta d theta. This is the most important property which we will use in example, and this property is also known as trigonometry form of beta function. Okay, so to prove this we have first definition of beta function. Now here one concept, and this concept will also use in example. Okay, so if minus is there, then after minus whatever the term, you have to suppose that term is equal to sine square every time. This is our concept. So we will take x is equal to sine square at theta. So dx is equal to 2 sin theta, and differentiation of sin theta is cos theta d theta. Now change the limit. When x is equal to 0, if you put here x is equal to 0, so square root of 0 is 0 and sine of 0 is 0, so theta is equal to 0. Similar way, if x is equal to 1, so 1 square root of 1 is 1, so 1 is equal to sine theta, so theta is equal to sine inverse 1, and sine inverse 1 is pi by 2. So we have new limit 0 to pi by 2. We will put all this concept, all this value in definition. So beta mn is equal to 0 to pi by 2. X is our sine square theta. Here this x is also sine square theta, and dx will be 2 sine theta cos theta d theta. Now by simplification, sine square raised to m minus 1, that means 2 multiply with this, so 2m minus 2, and 1 minus cos sine square is cos square, and cos square theta raised to n minus 1 gives 2n minus 2. So we have this two term, and sine theta cos as it is, and 2 comes out. Now we know the base same, addition of power, so 2m minus 2, and this is 1, so 2m minus 1, same way 2n minus 1. Okay, this hence it is proved. By using this, how we can solve the example? So to understand this, we have this concept. First write down this formula. Whenever this you will get, whenever you will get this form, you have to suppose 2m minus 1 is equal to whatever we have, and 2n minus 1 is equal to whatever we have. Then we will find the value of m and n. If we have m and n, we will put here. So we have this 2 into this, that p and q is equal to 2 goes this side, so 1 by 2 of this. So for example, if it is asked 0 to pi by 2, we have sine raised to 3 by 2 theta into cos raised to 4 theta d theta. So what will be the answer? So 1 by 2 and beta is ready. Now we have to find only p and q, that is m and n. That means this is equal to 2m minus 1. We have to suppose 2m minus 1 is equal to power of sine, that means 3 by 2, or you can take either, okay, because we have seen that it is commutative. And 2n minus 1 is equal to power of cos, that means 4. So 2m is equal to 3 by 2 plus 1, which is 5 by 2. 2 is in multiplication. If we take on the right side, so we have m is equal to 5 by 4. So here we have beta 5 by 4 comma n. So 2n is equal to 5. So n is equal to 5 by 2. So we have n is equal to 5 by 2. This is our final answer. Okay, this is the concept how we will use this trigonometric form of beta function. Okay, most important in each and every example. Okay, now we have one more property. Beta mn is equal to integration 0 to infinity of this. So let's start with the definition. We have this definition. Now we want to prove x upon 1 plus x whole raised to something. So we'll take x is equal to y upon 1 plus y. This is the method how we can remember that this property is proved like this. Okay, now after taking x, we will take differentiation. So dx is equal to differentiation of this by using division rule. Okay, by cancelling this y, we have 1 upon 1 plus y whole square dy. By changing the limit, x is equal to 0. If we put here, so y is equal to 0 and x is equal to 1, so y is equal to infinite. By putting all this value in this definition, we have this term, x is 1 y upon 1 plus y. This x is y upon 1 plus y, and dx is, as we have this, dx is equal to 1 upon 1 plus y whole square dy. By simplifying this, we have 1 plus y minus y upon 1 plus y whole raised to n minus 1. Y cancel, so 1 raised to n minus 1 is 1, and 1 plus y raised to n minus 2. Here y raised to m minus 1. So we have y raised to n minus 1. In denominator 1 plus y, 1 plus y, 1 plus y. So total in denominator 1 plus y raised to m minus 1 plus n minus 1 plus 2. So we can cancel this 2. So we have m plus n. And this is in the term of y, we want in term of x. So by changing into variable x, y into x. So we have the proof. Simple property. Okay. Now this property is very most important. Relation between beta and gamma. So whenever you will get beta of something, as we have seen 5 by 4 and 5 by 2, how we can solve this beta? By using gamma function. Relation between beta and gamma. So we have relation between beta and gamma is beta mn is equal to gamma m into gamma n upon gamma m plus n. Okay, so let's prove this one. So first we will use the property of gamma because we want the relation between beta and gamma. So property of gamma, this first property, gamma n is equal to 2 into integration 0 to infinity e raised to minus x square x is to 2n minus 1. So if you multiply gamma n, we will take this term. So we have gamma n is this. So gamma n gives only just m. Okay. By multiplying this 2 and taking 2 integration together, we have this double integration and these are the term. Now to solve this integration, we have to convert it into polar coordinate as we have seen in previous lecture. So same concept. So limit will be 0 to pi by 2 and 0 to infinity, limit of r, and this dx dy becomes r dr d theta. So by putting all this value, this e raised to minus r square here, this x is r cos theta, y is r sin theta, and dx dy is r dr d theta. Now this r raised to 2m minus 1, this r raised to 2n minus 1, and this r raised to 1. So total r raised to 2m plus 2n minus 1. So by taking 2 common from this 2, and e raised to minus r square as it is, and this is the term of theta. So we can separate the integral as we have seen in multiple integration. If given function is a multiplication of 2 variable. Okay. So we have this integral becomes this in 2 parts. It is clear seen that this is our beta mn and this is our gamma m plus n, because gamma this 2m minus 1. Second property as we have used this. Okay. Now make subject beta mn, we have gamma m, gamma n upon gamma m plus n. This is the relation between beta and gamma. Okay. So you can use beta 2, 3. That means gamma 2 into gamma 3 upon gamma 2 plus 3, that means 5. And we know how to solve gamma. Gamma 2, this 2 is positive integer, so 1 factorial. Gamma 3 is 2 factorial. Gamma 5 is 4 factorial. And we know how to solve factorial. So beta convert into gamma and gamma into factorial. We can solve it. Okay, so this is most important, most IMP property. Okay, this relation. Now another most important property is duplication formula, or we can say that Legendre's formula. Okay, formula is gamma m into gamma m plus half is equal to under root pi into gamma 2m. If we have this m, then gamma 2m and 2 raised to 2m minus 1. So how we can prove this? So let's start with the property of beta. We have beta mn is equal to this. This is the trigonometric form of beta function. Okay. Now we will put n is equal to m. So this n becomes m, this n becomes m. So we have the sine theta cos theta whole raised to 2m minus 1. Now multiply 2 and divide by 2. So we have this term becomes sine 2 theta, and we can take 1 by 2 outside by taking this power. So we have 2 raised to 2m minus 1, and this is sine 2 theta. Now we will suppose this 2 theta. So first write down. Now take 2 theta is equal to t. So 2 d theta is equal to dt. So we have this d theta is equal to 1 by 2. Okay. And theta is 0. When theta is 0, t is 0, theta is pi by 2. So t is pi. Now put all this value here. So we have this. We can cancel out this t. So sine raised to this. And here cos is not there. So we can write cos t raised to 0. Now this is pi. So we cannot use that property. The 2 time integration 0 to pi by 2 sine raised to something cos of something is equal to beta mn. For that we need this power or this limit pi by 2. For that we will use this definition, this property of integration. Okay, if 0 to 2a f of x dx, then we can use 2 times 0 to a if f of 2a minus x is f of x. Here we have this 2a is pi, and we know that sine pi minus t is sine t, because pi minus t is second quadrant. In second quadrant, all as t is second quadrant, sine is positive, so sine t as this. So we can use 0 to pi by 2 and this. Now suppose this 2m minus 1 is equal to 2m minus 1, so m is equal to m, and 2n minus 1 is equal to 0, so 2n is equal to 1, so n is equal to 1 by 2. This is in minus, so if you take on the right side, so plus 1. So this is our beta m comma 1 by 2, and by using the relation between beta and gamma, gamma m, gamma 1 by 2 upon gamma m plus 1 by 2. Now we can cancel gamma m and make this subject with this multiplication. We have this proof, and gamma 1 by 2 is equal to root pi. This gamma 2m is here, and 2 raised to 2m minus 1 as it is. Okay, so this is the proof. You can check this proof and the previous proof, that relation between, by rewinding this video and pausing this video. Use pen and paper so you can understand better. Now we have some examples. So first example, find the value of beta 3 by 2 and 1 by 2. This is our m, this is n. As we have seen the relation between beta and gamma, beta 3 by 2, 1 by 2 is equal to gamma m, gamma n upon gamma m plus n. Now we have the definition of gamma, this m, gamma n plus 1 is equal to n gamma n. And as I taught you shortcut, subtract numerator from denominator. So 3 minus 2 is 1 by 2, and now 1 minus 2 is not possible, so gamma 1 by 2 as it is. So we have 1 by 2 and root pi. Okay, same way root pi. So 1 by 2 root pi, and gamma 2 is 1 factorial, as we know that it is 2 is our positive integer. So 1 by 2 root pi, so we have pi by 2. Simple. Similarly, we have second example that you have to solve by yourself. Okay, by pausing this video, then you can play the video. Okay, so pause the video and start using pen and paper. Now I am just giving one more formula. If you have sum like this, so you can use this property of gamma. One remark of gamma, you can say gamma n into gamma 1 minus n gives pi in upon sin n pi, if you have this n. Okay, so here this 2 by 3 is written as 1 minus 1 by 3. You can check this by taking LCM. 3 minus 1 is 2. Ready? So this is our n by this. So pi upon sine n pi. So we have pi upon sine n is 1 by 3 pi, and 1 by 3 pi, that is pi by 3. And we know the value of sine pi by 3 is, yes, root 3 by 2. So 2 goes to numerator, and this is our final answer. So this is also one of the most important result. Note down all this result. We will use in example somewhere, wherever we need. Okay. Now we have one more example. This is the example like this. Now, as I told, when we proved that trigonometric form of beta, if we have minus is there, then we will suppose the entire term with sine square. Okay, so y cube is equal to sine square, but here 8 is there. There in that property we have 1, so we just suppose only sine square, but here 8 is there, so we have to multiply 8 also. So y cube is equal to 8 sine square theta. This is the concept, this is the logic, okay, that you have to remember, so you can solve each and every example. Then after, the process is same. Make y subject, So taking the cube root on both sides. So cube root of 8 is 2 and cube root of this is 2 by 3. Okay. Now differentiation of y is dy. 2 as it is. Differentiation of sine raised to 2 by 3 is 2 by 3. Sine raised to 2 by 3 minus 1. So it is minus 1 by 3. And differentiation of sine is cos theta. By changing the limit, when y is equal to 0, theta is 0, y is equal to 2 to cancel out. So it is 1 raised to 3 by 2 is 1, and sine inverse 1 is pi by 2. So automatic limit will be 0 to pi by 2. Okay, that's why we are supposing this. An entire y cube is equal to sine square, but we will multiply 8 because 8 is here. Whatever here, we have to put here. Okay. Now, by putting all this value, 0 to pi by 2, y is our this 2 into this, 8 minus y cube, that means 8 minus this, and dy is entire term, 4 by 3 this. By simplifying this, we have this term. By cancel out and simplify, we have this term. Now, after getting this, we have to compare, as I told, 2m minus 1 is equal to 7 by 3. And 2n minus 1 is equal to 1 by 3. So, we have this 7 by 3 plus 1. That means 2m is equal to 7 by 3 plus 1 is 3. So, 10 by 3. And if we take 2 on the right side, so 2 goes to denominator. So, cancel out to 5 by 3. Similar way here, we have 2 by 3. Now, we have this beta and 1 by 2. So by cancelling this 2, we have 16. So 16 by 3. And by using relation between beta and gamma, we have gamma 5 by 3, gamma 2 by 3 upon addition of this 2 by 3 plus 5 by 3, 7 by 3. By simplifying this, we have this by using the gamma. Subtract denominator from numerator. So 2 by 3 and gamma 2 by 3. So this is whole square. And by simplifying this, we have the final answer. Because we don't have the value of gamma 1 by 3 and gamma 2 by 3, so we will put as it is. If it is gamma 1 by 2, then we have the value of gamma 1 by 2 is root pi. Other than that, we don't have any value of gamma. Okay? Same way, second example, in this example, we have concept if plus is there, at that time you can mark that we have infinities here. So entire term is supposed by 10 square theta. Bus. This is the difference from previous example. Other than that, all entire steps are set. That is make x subject, then derivative, then limit. So limit gives automatic pi by 2 because of infinity, and 10 inverse infinity is pi by 2. Okay. Now put all this value here. By simplifying this, I cancel out this and convert this tan and sec into sine and cos. So we have this, and then as I told, suppose power of sine is 2m minus 1 and power of cos is 2n minus 1, 7 by 2. So by simplifying, we will get m and n. So we have beta this and 1 by 2 because this is entire formula. So this 1 by 2 as it is, and we have integration of this is 1 by 2 of this. Then by using relation between beta and gamma, this is 1 by 4 and this gamma m gamma n upon gamma m plus n. By simplifying this 3 by 4 as it is, but this 9 minus 4 is 5 by 4, then 5 minus 4 is 1 by 4, and then 1 by 4, 1 minus 4 is negative, so we have to write down gamma 1 by 4. By simplifying this 3, we have 5 by 128, so we have remaining gamma 1 by 4 and gamma 3 by 4. 3 by 4 can written as 1 minus 1 by 4. So here we can use gamma n, gamma 1 minus n is equal to pi upon sine n pi. This formula. Okay, we already used it, that's why I am not writing here. I'm just given here. Okay, so here n is pi by 1 by 4. So 1 by 4 into pi gives me pi by 4. Inside pi by 4 is 1 by root 2. So 1 by root 2. Root 2 goes to numerator. So we have 5 pi root 2 by 128. This is the example. Similar, we have this DIYs that you have to solve. As I told, if minus is there, you have to suppose sine square. Plus is there, you have to suppose tan square. and in trigonometry you can use directly. Okay, so these are the example that you have to practice, and as I told, more practice make you perfect. So use pen and paper in each and every lecture and make one notebook so you can understand better, and you can ask me whenever you have doubt. So thank you for watching this video. We will see you soon with next chapter, small chapter with small topics. Thank you very much.